Okay, so here's an example of a critical path method schedule, and we're going to crash this to compress the overall duration. Pause your screen right now and read this example, and I'll go over the solution with you. So here's our network diagram. First you want to determine what the critical path is. That's easiest to do by looking for which activities have zero float. So for this example, our zero float activities are A, B, E, F, and J, all zero float. And then we're going to go down to the crash tables. So here you'll see that we first need to determine what our cost difference is from our normal and our crashed, and then our duration difference from our normal schedule and our crash schedule. So first, to get our cost difference, you're going to take your normal duration, or you're going to take your crashed cost minus your normal cost. That'll give you $400. So for this one, it's 12,400 minus 10,000. That gives you $2,400, and so on. And then for your days difference, you take your normal duration minus your crash duration, and that gives you the amount of slack you have to shorten each activity. So 3 minus 2 equals 1, 6 minus 4 equals 2, and so on. Now, to determine your cost slope, you want to do dollars over days. That's how I remember it. So you'll take your $400 divided by 1 day. That equals $400 per day that you accelerate this activity. We only have one available day, so that's the most we can do. For activity B, you will take 2,400 divided by 2 days, and that will give you a cost of $1,200 per day, and so on. So next down here you have your original contract schedule, which is days cut 0, your total project duration, that's your critical path, which we determined up here, A, B, E, F, and J. Down here we have our direct costs, increase per day, none, we haven't increased anything yet. Then you have your direct increase in costs for the total, none yet. And we have our total direct cost. Now our total direct cost is from our normal schedules, total activities added up. So that's $86,000. Then you have your total indirect costs minus bonuses. Right now we don't have any bonuses because we're finishing at 28 days. So 28 days times our $500 overhead cost equals $14,000. You sum up your total direct costs and your indirect costs, that gives you a solid $100,000 if you were to finish the project at 28 days. Now let's say we want to accelerate the project 1 day, and we'll start out with finding our cost slope here. You want to accelerate the critical path, the first critical path activity that has the absolute least amount cost per day. So this is H, that's $200 a day, but it's not on our critical path, so that will do us no good. A is a sum of $400 per day increase, so this is what we're going to start out with. So we take 1 day out, which results in days cut 1, project duration goes from 28 down to 27. The direct cost increase is going to be $400 more because that's what it costs to accelerate that activity. The total is $400 more, and then you take your $86,000 plus that $400, and you get $86,400 total direct costs. Now when you go down to your indirect costs, you notice that that goes from $14,000 down to $13,000. You gain $1,000 by taking $500 out of your overhead since you're on the project for one less day, so you have $500 less overhead. $500 in your bonus clause. So that gives you a total of $13,000. So your new project total cost is going to be $99,400, which is $13,000 of indirect cost, your $86,000 normal cost, and then your $400 to accelerate that one activity. So when you go down here into your critical paths, you could see that we still have this A, B, E, F, J. That's our critical path. It remains our critical path as it's been shortened to 27 days. And you can continue to do this for up to 8 cycles. Normally, you will not have all of your paths equal 20 days. That was a coincidence for this problem. But when you go back to the question that was asked, question 1, determine the total project cost to compress the schedule to its shortest possible duration. That would be 20 days, and that would cost you a total of $102,500. Question B, or question 2, was to determine the optimal project duration based upon the latest or the least project cost. Now, if you look at all your cycles, it plateaus at cycle 3, where that's going to be your sweet spot between the overhead costs and the bonuses compared to the cost to accelerate those activities that you changed. So that's going to make your project cost $98,400. So you just repeat those steps over and over again, and you compare your critical paths, and you'll be able to crash your schedule without a problem. If you have any questions, feel free to contact me in the comment box, and I'd be happy to answer them for you.